Hello everyone. So today we are going to solve question number 643, maximum average subarray 1. Okay. So in this video I am going to discuss two approaches to solve this question. First one is going to be brute force, second is the sliding window. This is going to the first video for sliding window problem. Okay. So let's discuss the brute force approach and I'll discuss what the question demands right here. So basically what you the question says maximum average subarray. What this subarray means is the a part of an array. Okay, a part of array is a subarray. Here in this question, what you have to calculate is find the maximum average of that subarray. Okay, so basically what you have to do is you have to pick a subarray of the required size, then you have to calculate its average, and then you have to uh, move the move towards the next sub array, and then you have to compare it, and then you'll get the maximum average subarray. Okay, so there's one side here in this question that rather than focusing on calculating maximum average, you can just focus on calculating maximum sum, and then what you can do is just calculate the average by dividing by k in the end. Okay, so as you can see here, these are the steps to be followed for the brute force approach. What you can do is you can start with a fixed starting index I for the subarray. So let's say my starting index here is 0. Then you take the next k elements, next k element being 1, 12, minus 5, minus 6. You have to compute the sum and find the maximum. And since initially our maximum will be 0, now after calculating 1 plus 12 plus minus 5 plus minus 6, which is equal to 0, again our maximum sum reaches 0. Okay, and then you have to move one step. So rather than starting from 1, now we are going to start from 12. Okay, and we are going to pick the subarray like this. So 12 minus 5 minus 6 and 50. This time 50 will be included and 1 is excluded. Okay, check. After checking all the subarrays, divide the maximum sum by k to get the average. Okay, so initially we have to, or I will move from 0 to n minus k. Okay, this is important for uh, generating the loop. Okay, so I belongs from 0 to 6 minus 4, here n minus k, which is equal to, so we are going to basically going to get 3 iterations. Okay, so here are those 3 iterations. Okay, first iteration is this one where we started from 1 and we ended at minus 6. Here the sum is 1 plus 12 plus minus 1 plus minus 6 is equal to 0, and our maximum is still 0. Okay, sum was 0. Then we are going to move a window from this part to this part. So 1 is excluded this time and 50 is included. Now the sum will be 12 minus 5 minus 6, 50 is equal to 49. So our maximum is 49. Now we are going to move again, and now we're going to have this subarray. So minus 5, minus 6, 50 and 3. These two are excluded this time. Okay, so this is going to be sum as 42. Maximum is still 49. Hence we just reach the end of the array. So what we are going to do is we are going to return the answer as max divided by k. So max being 49, 49 divided by k is equal to 12.75. And since in this question we are demanded to return as double, then we have to do implicit casting over here. Okay, so this is the time complexity to solve this question. Each window takes O of k because k is the window size. Okay, the total windows will be n minus k minus 1, which can be set as O of n. So the overall time complexity will be O of n into k, which is basically for a bigger input, it will be O of n square. Okay, so this is easy approach. Let's code this one. Okay, so what you have to do is first let's generate a utility as int n is equal to nums dot size. Now what you have to do is you have to iterate, and you need one variable to store maximum. Okay, so int maximum is equal to 0 right now. Okay, now, or no, you have to initialize it using int min. Why? Because we also had negative values in this array. Okay, so you have to initialize using int min. Okay, so for int I equals 0, I less than n minus k, I plus plus. Now what you have to do is you have to calculate the current sum. So int current sum is equal to 0 right now, and then you have to iterate again. So for int I equals, for j equals I, j less than I plus k, j plus plus, current sum plus equals to nums of j. Okay, now you have to compare them. Okay, so maximum will be updated like maximum if it's already greater or the current sum that we have calculated. Okay, current sum, right? Now what you have to do is you have to return the maximum average. To return maximum average, you have to return. Now you have to do implicit casting, so you have to do double, and then you can just return maximum divided by k. So let's see this one. Let's run this, and it's accepted. Let's submit this. So we got a time limit exceed in this method. Obviously it's an quadratic time complexity method though, so we have to optimize this solution. Okay, now what you have to do is you have to use sliding window approach. Okay, so let's discuss sliding window approach. So in this approach, what you have to do is we'll be having a sliding window, and we'll be on our way calculating the sums. Okay, so basically what you have to do is first you have to calculate the first window from I is equal to 0 to I is equal to k minus 1. Same constraint, same insights. Okay, now what you have to do is next you have to slide the window by one step at a time. So from I is equal to k to I is equal to n, we are going to move one by one by one. Okay, update current sum, update the maximum sum if sum is larger, and then repeat until the end of the array, and then in the end return the maximum sum as maximum average. Okay, just using this same formula for double. Okay, so you can see here the formula will be first you have to calculate the first window. Okay, so this is the part for the first window. So for first window you have calculated the maximum, which is going to be 0. Current sum is also going to be 0. Now what you have to do is you have to add the new incoming element, which is going to be 50. So you can see from here to here the new incoming element is 50. We added 50 and we subtracted 1. So it's going to be 50 minus 1 is equal to 49. Okay, 50 minus 1 is equal to 49. Same way, we are going to iterate for the next window, which is going to be, now we are going to remove 12 and add 3. So current sum is 49. 49 minus 12 plus 3. So it's going to be 42. But since the maximum is still greater, so we are going to keep it as 49. Okay, then we are going to return the max divided by k for average. Okay, same double implicit casting. Okay, the time complexity here will be each window sum takes off one time. Okay, since we calculated the first one using of k, and then total windows are of n minus k. So the time complexity will be of n minus k, which is converted to O of n. Okay, so the intuition main being here is after the current sum, you just have to remove one element, which is nums of I minus k, and you have to add one element being nums of I. This is the main intuition why we are using sliding window approach. Okay, so let's code this one. So what you have to do is for first window. Okay, first window, this is the first thing that you have to do, and we can just initialize and maximum sum is equal to int min. Okay, and then what you have to do is for first window you have to iterate it like int I equals 0, I less than k, I plus plus, and you have to do int current sum is equal to 0. You have to add this to current sum, so current sum plus equal to nums of I. Now you're going to place maximums, the value of current sum into maximum sums. This way you're going to have context of the first window. Okay, so max sum is equal to current sum. This way we have built till this part. Okay, now we have to iterate for the rest of the part. So for int I equals k, I less than n, I plus plus, current sum plus current sum is equal to current sum plus nums of I minus nums of I minus k. This is the same thing that we saw in the board. Okay, and then what you have to do is we have to update maximum. So max sum will be equal to max of max sum if it's already maximum or the current sum. Okay, and in the end we obviously know we have to return it using implicit casting. So return double max sum divided by k. Okay, so this is the first window and this is other windows. Okay, so let's run this. Let's submit this. So you can see this is the most appropriate way to solve this question. Okay, so that's all for today. Thank you for watching.